public clouds. And yes, usually the customers I talk to have standardized on one particular cloud provider, but yet will also admit that they have bits and pieces running elsewhere. So the answer to that dimension, if you will, or that dimension is we need to have software that runs in all kinds of places. And the second dimension of this is what is that software? What are the workloads? And there again, I feel like we went from a world of extremes that basically says, here's our existing applications that were built many years ago based on past application architectures, and we're just going to leave that alone. And we're going to focus on new, so-called cloud native application development, and that's where we're going to put all of the investment. Only to then realize that most of the money actually goes in the IT budgets, goes into maintaining existing applications, keeping them alive. So that I feel like here again, we're now kind of in a all over the map, if you will, where existing applications sometimes are being lifted and shifted into new places without really a lot of change. Sometimes they get refactored to account for new runtime models, or they get enhanced using additional functionality that becomes available. And then obviously this new cloud native application development style with using 12-factor apps and microservices and so forth is also still there. So the second dimension, if you will, is what kind of workload. It means everything, but from old to new and everywhere in between. So if you think of that as kind of the landscape that we're in, we need to have solutions that can run in all kinds of places and can run all kinds of application workloads. The next and third dimension to all this is just plain technology. And so we did make a pretty big decision, I think, a number of years ago that we're going to go all in on container. And we do believe that, and we can argue over how quickly that will happen, but we do believe that ultimately containers will be the de facto and the default way that companies use to run software of all kinds. I mean, there's always going to be exceptions, but that's going to be the default way. And it gives us a number of benefits, of course. More lightweight, it's portable, and so forth. And you see the bullet points being listed here. But simply saying I'm running something in a container in itself doesn't provide a lot of value. The value really comes with then putting that in an enterprise context where I also need to go and say, I need to run this in a highly available kind of fashion. I need for it to be resilient. I need for it to plug into CI/CD DevOps processes and so forth. So the environment that we think of when we talk about enterprise applications and having a framework within which containers can run there. And there again, the decision that we made is not only are we going all in on containers, we're also going all in on Kubernetes. And even at the time when we talked about this, it was already emerging as kind of to be the winner, if you will, in the container management framework kind of space. Not to say it will always stay that way, but for now, I think the whole industry is kind of working with Kubernetes. So those three dimensions, and we actually then said, okay, we're going to take our entire software portfolio and we're going to containerize it and we're going to run it on Kubernetes. And I'll talk a bit more about how we did that and how that went. In that time frame also came the decision that IBM was going to acquire Red Hat. And even though Red Hat is still a completely independent entity, obviously, the stack that Red Hat has, is something that we want to leverage with our software offerings. And if you think back to the dimensions that I just mentioned, Red Hat kind of offers all of that, a strong stack that starts out with Red Hat Enterprise Linux, OpenShift, and on top is the leading Kubernetes distribution, if you will, and then the ability to run that in all kinds of places and having support for all kinds of flavors of applications. So it kind of was the perfect fit to become the underpinning, if you will, of the software that we're building. And that has kind of culminated in this picture, and this is obviously architecture, right? But if someone were to go, okay, what's IBM's kind of software architecture that we're building right now, that we're building against at the highest level, this would be it, right? Well, we have this strong notion of the platform in between that is OpenShift based on RHEL. That gives us support for all the stuff that you see at the bottom, so we can run it in all kinds of places. And it acts almost as a level of indirection, if you will, from our software, so that we can now take the hundreds, literally hundreds of offerings that we have in the market, and we have a common landing place for it. We have a common target that that software can get integrated against as part of containerization, like I mentioned. And a nice side effect of that is that we can also take advantage of a rich ecosystem that already exists, and we can expand and enhance on that accordingly. So that kind of sets the stage, right? So like I said, a few years ago, we said, make a couple of technology decisions, go all in on this. And then Red Hat came along, we're saying OpenShift is the platform that we want to run this on. And we're kind of doubling down on that. And then we started taking our software and group them, and you see the high level boxes here, into these things we call Cloud Paks. But I'll get back to that in a second. Before I do, it really want to go back to the beginnings of all of this. So we said, let's containerize everything. And at the time, also, we did something that I would say is still to this day relatively disruptive for IBM, in that our different development teams, and we have teams and labs all over the globe, we're kind of used to be fairly autonomous in their decision making, and how you are successful in your respective market with your respective customer audiences. And we now said, if we containerize, let's do that in a consistent way across the board. Let's all follow the same standards. Let's all follow the same best practices and conventions. And that, to this day, sometimes is a challenge, simply because it's such a large team, thousands of developers, literally across the globe. Bring them together and all kind of follow a common model. And so we've been building this up for the past few years. Like I said, we've established a central team that I'm part of that is basically defining the rules, if you will, for how we do this. And it started out with something as simple as, I remember the conversations, well, we did a survey about, of all the container images that the teams are building, what are they using as the base OS? And it came back, and I think we found at least 16 or so, if I remember it correctly, 16 different base OSs that were used across the board, each with their own pros and cons and their own kind of characteristics. And we said we want to consolidate that. We want to make it all based on a common base OS. And needless to say, we picked UBI for this, which is kind of RHEL. We couldn't use RHEL until that point, until UBI came out, because there was no way to redistribute RHEL as a base OS with our commercial offerings. And so that's why we're almost forced into other options. But as UBI came out, we went all in on that. We took all of our images and rebased them. We're not at 100% at this point, but we're fairly close. So that's not even a debate anymore, that any team that goes and writes containerized software, that they use UBI as the base image. And then we also go and certify that, but I have a separate couple of slides on that. So it starts there, and then we go, okay, how do we orchestrate things? How do we package things? How do we start adding some operational characteristics to all of this? Another example for a technology decision that we made at the time is that we chose Helm as the way to orchestrate and to some degree package our offerings. So we had Helm charts for everything. And for quite some time, we majored on Helm, as that was going to be the way in which we would also enforce all kind of conventions that we had come up with. We have since, or we're in the process of transitioning away from that, and I'll get back to that point later on. But Helm is kind of where we started, and I think it served us well, but it ran into some limitations, and so we decided to transition away from it over time. So all of this stuff then to say, we have a whole set of rules that we built up. We started building what ultimately came to what we call the certification process. This is an IBM internal thing. It's an in-house thing that we build up as a way to not only define and articulate kind of the rules that we want everyone to follow, but also having a way to enforce them. And so we have a central CI/CD process that all the content is being fed through. There's very limited automated testing to go with it, and that's a challenge that we have, admittedly. But we're also we're scanning and lintering and checking on that code. So we're looking at the real deployments, and we're making sure that the rules that we have put in place are actually being followed. It's not 100% automated and self-service, but again, that's the goal of what we want to get to. And in detail, it's all the things that you see on this slide here. So there's guidelines and conventions. Overall, I think it's around 150 or so criteria that we've developed that we are mandating or prescribing, if you will, to all the development teams within IBM to follow in support of A, being consistent, and B, being what we call enterprise grade. So it goes into things, especially security is one that I like to point out, where we have rules about how you deal with vulnerabilities. We scan our images every day. We have rules about how to manage secrets, about how to deal with SCCs and things like that. And in fact, it's on my bullet list of topics to revisit, at the end of this presentation. But this gives you a kind of a feel for the process that we run there. And so this really gives us an internal way of saying we give every piece of content our stamp of approval before it goes out. And that gives us the confidence that the solutions that we publish and give to our customers are actually up to snuff, so to speak. Now, and it was showing on the previous slide already, and I mentioned it, we're building this on top of the Red Hat certification program. So we're all in on that. We've been doing Red Hat image certification for a little over a year now, I would say, maybe a year and a half. UBI started all of that, like I said, so that happened, it seems like 20 years ago, but it happened in the earlier parts of last year when we started. We now, just to give you a feel for the volume of code that we're dealing with, I believe last time I checked, we had about 6,000 distinct images in that process and in that site. And interestingly, when we first started certifying, we actually brought the site down for a while because it wasn't really ready for the kind of volume that we were throwing at it. But that's been fixed now. There was a lot of work we did with the Red Hat team on getting the right APIs established so that we could automate it and so forth. And I think we've come a long way. And we're now building on top of that with operators. And I hinted that we're transitioning away from Helm. We're now going towards operators. We're all in on the whole Kool-Aid of operators, being kind of the management pattern that we want to implement across the board, just like it's implemented in OpenShift today already. As part of that, we will certify all of our operators. We have just begun on that journey. We're not operator-based across the board. Again, I'll talk a bit more about operators later. But that then becomes kind of the foundation for this add-on certification that we do. So and that's why it's shown here as kind of a stepping stone. So we start with the image, then we go into the operator, and then we look at how everything gets deployed, orchestrated, secured, how we deal with rolling upgrades, how it's being versioned, all those kinds of things. And we basically have a rule book, if you will, that shows how we're doing that. Now, we've applied this for a while. And like I said earlier, this is basically what it comes down to then is we've taken the capabilities and offerings that we have across IBM, across large parts of IBM, not all of it, and stuffed them into these things that we call Cloud Paks. Those are the products that we sell. They're assemblies of related capabilities. I always say each Cloud Pak supports a specific user experience for a specific persona and specific set of use cases. But it all goes on top of what I just said in terms of our own certification and containerization, running it on OpenShift and so forth. And that's basically how we then come to this view. And we say we have these six products, 6 pieces of software, if you will, that run in all kinds of places by sitting on a common platform named OpenShift. And we claim that they're enterprise ready, so to speak, and we're having the process to show that we use to make that work. So that's kind of what we have on the truck today. And like I said, we've been on this journey for a few years now. The Cloud Paks have been out for a little less than a year, so they're still a fairly new thing for us that we have in the market. But it is definitely something that we declare as kind of our strategic way of bringing software forward. Cloud Paks. So if you buy any piece of software from IBM, it will be a Cloud Pak and it will run on OpenShift as kind of the default mode, so to speak. As again, there's always exception to that rule. So now that we're about a year into this whole thing, the question then is, all right, what do we do next? What do we want to do when we grow up, so to speak? And so we've laid out, and I have that on this slide, kind of a set of technical priorities, things that we work on. This is the bucket list, if you will, of what we're doing right now. And I've sorted them into four categories, if you will. And the first one is all about, I think what we've noticed is that the way, and hopefully it was, you know, if you go back to this picture here, you can see that we've built them as verticals. Like I said, these verticals are all in support of specific personas and experiences. What we found, though, is that a lot of times when, and this is not just our customers, this is our own IBM teams, for example, or partners or GSIs are writing applications that are saying they have a more horizontal view of everything. They said there is a number of services at my disposal that I want to be able to orchestrate in a way that supports my particular application. Think of it as like building your own vertical within the scope of that application. And so that is something we call CrossCloud Pak Integration. That is just the ability to consume capabilities from across the board. And there's a number of activities that we have going on in that respect. One that I want to point out is something we call service binding. Sometimes sounds like a tiny little detail, but I think it's tremendously important that we find easy and automated and dynamic ways of connecting services to the applications that take advantage of these services, and do so in a really hybrid way. In other words, do so across, you know, on-prem, off-prem, and so forth, and have a standard for doing that. There is an activity that we're involved in together with Red Hat and a number of other vendors to create what's called a service binding. There's a spec for it, and then ultimately there's a service binding operator, which is aligned with, you know, using the operator pattern, if you will, to implement those kinds of things. And that should give us a common way of then exposing services, service instances to applications that want to consume them in a consistent way. And again, being able to do this binding at runtime, if you will, and not at coding development time. So that's a big part of this. Second bucket here is the operational model. And sometimes that sounds a bit dull and boring, but it really comes down to where the bang for the buck is. And I said right in the beginning that a lot of IT budget today goes into the management and maintenance of existing applications. And that's something we want to tackle. And we want to have a common and consistent operational model across all the software that we have. We want to leverage everything that Kubernetes and OpenShift give us for that. And so that becomes kind of the operational model in terms of how you interact and how you manage, how you upgrade, how you scale, how you secure your software. And the mechanism, or one of the important mechanisms that we use to do that, is operators, of course, right? And again, it kind of almost goes without saying that, you know, again, I think of it as a design pattern that is very helpful in doing end-to-end lifecycle management. And now talking about that, I mentioned Helm. It has its limits earlier, and I truly believe that Helm is really good at deploying software, maybe doing upgrades, but that's kind of where it ends, because it's a one-way, kind of a fire and forget mechanism, if you will. And what I think is really powerful about the operator model is that it allows you to keep track of the resources that are out there, to basically watching and monitoring resources, and then being able to do automated reconciliation on those resources in case something in my target environment changes, and making that a way of enforcing, you know, the desired target state, so to speak, to stay in place. And to some degree, that's just an extension of something that Kubernetes has been doing from the very beginning. Kubernetes has a set of abstractions like deployments and stateful sets and so forth that it defines, with then runtime elements, controllers that make sure that those things actually remain at their desired target state, so to speak. And we're now expanding that, if you will, onto the workload level and using the same mechanism. And that ultimately will get us into truly end-to-end lifecycle managing those target workloads to a degree that Helm just simply couldn't do for us. I sometimes I get feedback where I've heard also vendors saying that they feel that operators are kind of a Red Hat proprietary thing and OpenShift only, and that we're locking them into this platform when we're doing that. And I usually don't think of it that way at all. I think of it seriously as a design pattern that goes across all of Kubernetes already that we're now expanding on. And that's not something that is a locked-in proprietary technology at all, in my opinion. But again, we could probably have a debate on that. And so that then helps us drive things like install the update, migrate, things like that. We need to do some metering of our software and so forth. So that all kind of ties to this operational model that's based on the idea of using operators to do it. The third bucket then is, I call that hybrid cloud consumability. This goes all the way back to this runs anywhere kind of idea. Obviously, we run things on all kinds of hardware platforms. We've done a lot of work just lately to expand both OpenShift and then our Cloud Paks onto our Power Platform into mainframes running Z-Linux, so that we can truly run anywhere on-prem regardless of hardware architecture. We still have some work to do there, but we're on a good path, I think. And then going into public clouds, obviously we have everything running on the IBM cloud. That's very near and dear to us. Needless to say, we want that to be the best place to run OpenShift or any kind of software from IBM. But we also acknowledge the fact that there's a very hybrid world out there, and so we need to support other clouds. And I just mentioned AWS and Azure are just examples, but I mean, that's obviously a direct reflection of the reality and the landscape that we see out there, and we need our software to go with that. And often enough, it really puts a lot of good pressure in a good way, I think, onto our internal processes. I just mentioned earlier, we have an internal central CI/CD process where we do governance, where we do the certification, we do packaging. That's also where we need to plug in kind of automated ways of running and validating that things can run in all kinds of places, so that we can truly stand behind this notion of Cloud Paks run anywhere. And there's a lot of ongoing work into that to improve our processes, to become more agile in terms of how quickly we can apply patches and do updates and so forth. And last bucket is about ecosystem. We have a whole team that does that works with vendors and saying, how can I relate and associate and affiliate my own solution with, the Cloud Paks that IBM has, and what does that mean? In that context, we're also looking to publish at least parts of we've already done that to some degree, publish our certification criteria, because we do believe that they reflect a lot of the best practices that are out there in the industry, and there's no reasons why we wouldn't let others benefit from that, if you will. So those are the priorities. This is basically the bucket list of all the things that we're working on right now. I have a couple more detailed slides. I always use this picture, and it's admittedly fairly high level, but use this picture as a way to articulate how we want to go and, have these verticals that we have today, but then also allow a more horizontal view across them. And the way we're doing that is by taking all the individual capabilities in the Cloud Paks, have an operator for each one of them, put that in an operator catalog in OLM, and then let you use that, from within whatever your respective developer experience is, to plug these things into your application. And use things like I mentioned earlier, service bindings and so forth. Even though service bindings is something that we have to implement those, and we have to support those across the board, and that's work that's yet to come. And I mentioned earlier that that also gives us the ability to start creating applications that are truly hybrid, where an operator can represent not only a workload that would be deployed locally in the same cluster, for example, but also connect, simply tie to service instances that live in someone's cloud, be it IBM or somewhere else, and make that whole integration seamless, at least from an application point of view. So we are doing a ton of work, and this is just a really high level kind of mock-up that we created that shows how we want to have all our capabilities represented in the operator hub, have that installed in the cluster, so to speak, make that the way of how you install and then utilize and consume our capabilities. We have an operator catalog already in there that we shipped. It only has, at last count, I think a little over 10 different operators for our capabilities. We want to grow that over time as we roll out these operators and plug them all in there. I do want to make the point of the maturity model. I think that's hugely important. And here again, it shows kind of what Helm gives you. We can argue, obviously, about whether that Helm arrow should point a little further to the right, but that's not really the point. The idea being is that we need to ultimately get to the stuff on the right here, because to some degree, the things on the left are almost table stakes. Yes, we need to install and deploy, and we spend a lot of time discussing that, but we need to get into how can I now use this ability to watch resources and do reconciles and so forth, and how do I take full advantage of that? And then to us, it's always, and to me, it's always in how do I do that consistently across 215 different capabilities and other. And I think a lot of this, to be honest, is not so much in how do I implement the operator. It starts with actually the modeling of the CRDs. And I feel like I just had a conversation this morning with a team where I was thinking we need to spend more time on looking at the CRDs, making sure we have them appropriately modeled, that they expose the right level of detail to a consumer that is meaningful, and it's not necessarily easy to do that. And I think as we go to the things further on to the right, we're probably going to have to augment and enhance the CRDs and then the controllers that go with them to do that. By the way, we have, since it mentions Ansible and Go here, we have a small number of teams that are all in on Ansible operators. We started out looking at Helm operators, but then thought, they don't really give us the benefit of going all the way to the right, if you will, because you still have a Helm chart, you're just executing it in a different way. So we now have, and there was a bit of a skills burden, at least for some teams, to go with Go, so to speak. But I think we'll end up with the majority of our teams writing their operators in Go. That seems to become the standard that we're going for. Ultimately, and this is my last slide, or my next to last slide, is we want to have this all in the Red Hat Marketplace. That thing went GA, I believe, a couple of weeks ago. It's been out there as a preview for a while. And you see that we want to have Cloud Paks in there, so that then makes it easy to try them out, to purchase them all the way into then deploying them automatically. The Red Hat Marketplace, if you haven't seen that, has a way of letting you register your clusters and directly connect them, and then initialize the install of the operator, not of the end workload, but the install of the operator from within this marketplace. This marketplace is very operator-centric, by the way. So we're all in on that as well. We have only one topic, the one that you see here in there today. We're going to be adding others over time as we get to it. So this gets us 30 minutes, and we can. I just jotted down a bunch of topics that go more into what have we learned along the way, what are the challenges that we've seen, what went well, what didn't go so well. So this is kind of, mentally to me, just a helper of a few things we can touch on. But let me take a break there and see if there's some questions right away or comments, or if I should just keep going down the list here.
Thanks, Andre. I wanted to mention really quick, because I'm so glad that you said Red Hat Marketplace, and you're talking about integration between all the different cloud packs, as well as the thousands of developers, and the integration with Red Hat Marketplace was also a lot of work. So it's impressive how many different pieces all the teams took. Do you want to talk about that briefly?
Yeah, I mean, so for Red Hat Marketplace, on the one hand, it fit right into what we had as our strategy already. Like I said, we wanted to have operators as a means to not only deploy, but also manage everything we have, so to speak, right? And then we started meeting with the Red Hat Marketplace team, who basically said, we're going to have a catalog, and the things in the catalog are going to be represented by operators. We thought, okay, that's good, right? Because we're building these operators anyway, and we can plug them right in there. There's also the idea that in the Red Hat Marketplace, they want to ensure a certain level of maturity and quality of what's in there. And that's been done by basically saying one aspect of publishing your software into the marketplace is that your operator has to be certified. And so we then did a lot of work on making sure that we could actually do that, and what's the process for it, and what's the certification process? Can it deal with, like I said, we have the battle scars to show when we went for image certification in terms of the volume, right? So in terms of, can it handle the volume now that, well, the APIs hold up and so forth. And we're still on this day, we're having regular exchanges with the certification team at Red Hat. And then again, sometimes we say, well, we're IBM, we're just like any other vendor to Red Hat, and we are in that context. Like, we are one of the consumers, if you will, of that marketplace. We just need to make sure that we can plug into the process and that it avoids a lot of duplicate work that we already have, and a lot of comparing notes there in that respect. One of the aspects that, for example, comes up all the time is that, is it on here? No, that could have been another bullet point, is something we call air gap, right? Almost all of our customers, to be honest, are saying, we do not deploy things out of the internet. We will not pull things from the public registry. We need to have things in-house. We need to scan them. We need to vet them. We want to control and govern what our internal users consume. And therefore, we will never let anyone go out to the Red Hat Marketplace and just push a button and say, deploy this commercial software, because of the structure that they live within, right? So one of the things that I still feel like we need to figure out, and I know it's on the roadmap for that team, is to say, I need to have a disconnected flavor, if you will, of the Red Hat Marketplace that gives me the same consumption experience, but that does not necessarily require my target systems to be network connected to something that lives out there in the wild, because a lot of security teams that I talk to are seriously scared by that prospect. So air gap is always something to throw in the mix to say, we have that in almost every discussion. We're saying, here's how we could do things, and then someone will say, can I do that in an air gap way, right? And that needs to become kind of a design point from day one for us.
I know that, that's a question that's asked frequently for public sector and banks, and I know it's part of your roadmap when you get in there. We have a couple other questions. The answer is yes. And IBM Watson Software, will it be available as a Cloud Pak? Or it's part of the Cloud Pak, so not its own Cloud Pak. Do you want to?
Yeah, Watson is kind of an interesting one, because Watson is a pretty broad term. That's a branding that is applied to many distinct pieces of functionality, I would say. We have bits and to be honest, the answer is we have bits and pieces in our Cloud Pak for data. We have bits and pieces in our Cloud Pak for automation. We have some that are kind of sitting on top of the Cloud Paks as a separate offering. So the answer is, all the Watson software should follow, certification and all the best practices and all kind of the process that I mentioned. Whether they're going to end up in being sold as part of the Cloud Pak depends on the individual piece. Some of them are, some of them are not. It's not really our goal, I don't think, to have every piece of software IBM has ever written in a Cloud Pak. But we have it as a rule to say it all needs to follow, it all will be containerized, it all will run on OpenShift, it all will be certified and so forth. And then the question is, what's the product number that sits on it, becomes kind of a secondary issue, at least for me, from a technical perspective.
All right. Storage options for air-gapped.
Storage options for air-gap. So first of all, storage options in general, I would say that I keep saying we've been fairly unopinionated about storage in the early days. We basically said, and that's good, right? There's a defined level of indirection in Kubernetes that says a storage consumer will put out a persistent volume claim and then assume that claim can be, that those data requirements, so to speak, can be met. And then it's the provider that basically provides the cluster and the storage underneath that creates persistent volumes that can plug into those persistent volume claims. So we basically said, we state a bunch of PVCs, and we can tell you what kind of access modes we need, what kind of storage types we need, and then it's up to you, Mr. Customer, to figure out how to plug your storage into there. And to some degree, that's still the case because, like I said, it makes sense to have that level of indirection and not to have a tight dependency between an application and the storage that it plugs into. So I think that is good. At the same time, I feel that we need to be a bit more opinionated about it in terms of being able to go out to customers and say, and here's storage that we tested with, and here's something that we know works, and here's something that doesn't really quite fit our needs for, say, enterprise production level use. And so in that respect, I mean, what I can tell you what we're using internally as kind of our default test bed everywhere now is OCS. OCS is separately licensed, of course, right? It's a separate Red Hat product, but it's the easiest for us to plug into because it gives us all the access modes and file types and everything else that we need. And then from an IBM perspective, we have what's called the storage suite for Cloud Paks that has our enterprise storage management products that kind of plug into that seamlessly. Overall, though, it's obviously companies who embrace containers and say OpenShift and then Cloud Paks wouldn't necessarily make that the reason to replace their existing enterprise storage management systems, right? So there's always this aspect that we need to be able to connect to basically anything that's already out there. Now, for air-gap storage, if I were to interpret the question, what that means is basically when we say we want to run in an air-gap mode, and like I said, that means we cannot pull images from public registries. That means customers need to deploy their own private registry. And I know that Red Hat has an offering in that space, Quay, right? And there's others, and we see, I've seen a large mix of them, and I usually say it doesn't really matter. We need to have the ability to mirror, if you will, or clone all the artifacts that make up a Cloud Pak to a local place. And in general, the artifacts that we have are the images themselves and then the metadata that goes with it. The metadata lives either in operators, which then are images again, or in GitHub. And so ultimately, and we have a CLI basically that says you can take the inventory of a Cloud Pak and it gives you a list of all the images. So you can use something like OC Mirror to get those. And then you clone GitHub repos. And so then you can store them locally into whatever place you want. And then the challenge really then is to make sure that all of the references get updated, right? And so kind of what we're looking at, rather than updating every pod spec and pointing it to a new image registry now that is local, we're using the policy from OpenShift that I keep forgetting the name of, that is basically, I should really write this down because I'm drawing a blank every single time. But there's basically a way where you can, at the cluster level, define that ask for certain image registries should simply be redirected for a different place, kind of a DNS, if you will. And that seems to be easier to deal with than saying I need to go into every kind of resource definition and make all the updates so that everything points to the right place. So in general, I would say our air gap strategy is based on having an inventory that tells you what to pull from where and then to clone it, and then use tools like OC Mirror or maybe even Scopio to clone them. And then secondly, use cluster level definitions to update the references accordingly.
Thank you. I want to make sure we get into your list of topics because you have a really good list here. Do you want to jump into the stateful versus stateless? I know we talk about that a lot with Helm versus operators or different ways of managing.
Yeah, I mean, these things easily become a religious debate, I feel sometimes, because a lot of it, and I've seen a lot of things out there in public when it's like, what's the advantage of a container or what's the advantage of Kubernetes? And then they describe all the magic that happens. And I'm thinking, well, that only works if you have an application that's actually architected in the right way, that has stateless microservices, that has microservices to begin with, right? Not all the software that we have out there, and that's true, I'm sure, for any customer and any enterprise, as well as for vendors like ourselves. We have software that is not architected for microservices, that does not necessarily have strict separation of stateless versus stateful elements, and that are monolithic a lot of times. And that's why I put here few versus many images. You know, when we have a new product or a new offering coming our way, and they say, we're starting to containerize, I always ask, like, do you have 1 or 2 images or do you have 20? And just the answer to that question will tell me right away how that thing is architected, right? Where if they're saying we just have 1 image, then that means that's probably a fairly monolithic application architecture. And then we need to look into details of, can I run this can I run multiple replicas of that, right? Does that even support kind of an active mode of in a way that I can scale it, you know, through multiple pods, for example. Not every application is written in a way that it does that, right? I've seen commercial applications, industry applications, very successful ones, that go and store their state in the heap, right, within their code. And then you can't duplicate that, right? You can't have 2 of them and put a load balancer in front. It just doesn't work. It's not architected that way. So sometimes I feel like, you know, we have to make sure that the application actually fits, you know, all the bells and whistles that Kubernetes and OpenShift give me. And so we've been struggling with that, honestly. And we've even seen offerings that had to be rewritten because they just wouldn't fit this model. So there is a bit of pressure on existing software to kind of look at the architecture, look at how it's structured, look at where the state lives and how it's dealt with within the application, to then determine how it best can be containerized. So that's the first one. The next one here is base OS. Like I said, we went with UBI. That has worked pretty well. One question that we had in the beginning was, and it was every day a team would come and say, we have 3 packages that we need. They are in RHEL, but they're not in UBI. Where do we get them? And then we got to this point of saying, okay, you can add RHEL packages to a UBI base, and that's also fine, and that's going to be legal. We then got into a question of, there's 2 flavors of UBI, and there's a mini one or minimal, and to a lot of our teams, that's not minimal enough. They need something much, much smaller, and so that's a discussion we haven't had in a while. We should probably pick up on that to see where that's going. And then the use of scratch images to begin with, you know, where some say, I use a scratch image, can I certify it? And the answer is no, you can't. You can only certify if there's UBI inside, otherwise it won't work, and things like that. But overall, I would say having a common base OS has served us really, really well. I can only recommend it. It makes life a lot easier if you have a large portfolio. Also in terms of vulnerability scanning, right? There's a lot fewer vulnerabilities in UBI than in other popular open base OSs. Let me just put it that way. And that has I think it's a reflection of the maturity of RHEL in general, and I think that has worked pretty well for us. we haven't had a single customer push back against this, right? And say, no, we don't want that base OS in there. Mostly they don't really care, to be honest. Next point here, and I'm keeping an eye on the time here. We got about 10 minutes. So, and stop me, Karina, if there's a question that I should address. Otherwise, I'll just keep rattling down my list here. Tenancy namespace isolation is right now probably at the top of the list. We have assumed that we are expecting, and I think we still are, and we see some proof to that, is that most customers will ultimately end up with a large number of maybe relatively small or small in scope, so to speak, kind of clusters, so that each LOB or maybe even each application will get its own cluster and then get a high degree of authority on that cluster and basically mess with it as they see fit, so to speak. And we see that model. I talked to the head of infrastructure for a large Wall Street outfit just this week, was it, or last week, who then said that's kind of, they have a self-service in which they hand out clusters to individual organizations. They give them cluster admin rights and they say, go knock yourself out, right? But don't break anything. We also have seen the opposite, though, is where we've seen enterprises that have very few, very large clusters, right? And have a central cluster admin team that organizes and manages everything. And they are much more interested in isolating things that go onto this cluster from each other, and they use namespaces to do so. And that can only go so far, and it's led us a bit to a conversation about how do we need to structure our software on our install in terms of what namespaces do things go into. These customers, especially the ones with central clusters, are very sensitive to cluster admin roles, right? And they say you cannot deploy a piece of workload somewhere that has the right onto any other namespace than the one that it was deployed into. And frankly, in our software, we have cases where that's happening, where we need to do cross namespace kinds of things, right? And so I think it led us, like I said, to this somewhat philosophical debate that how good is OpenShift and Kubernetes? I think this is mostly a Kubernetes problem, to be honest. How good is it at multi-tenancy? How good and multi-tenancy to me is the degree of isolation of workloads, right? How good is it at keeping things apart from each other? And one of the things that makes that really hard for us is something as simple as CRDs being cluster scoped, right? We can, because we're doing everything with operators, like I described, that means the operators kind of need to live close to the workload that they manage, but then all of them have one or more CRDs that all of a sudden have cluster scopes. And it makes it impossible, to be honest, for example, to run two different operators with different versions on the same cluster, because they're going to trample over each other just starting with the CRD. So I feel like there's work in general to be done in the Kubernetes OpenShift space, if you will, to figure out what the right model for multi-tenancy is and how it can isolate things from each other. Right now, the way we work best is in situations where we can just basically take over the cluster. And like I said, in some cases that works well, in other cases it doesn't. Footprint is a big one. In general, I would say all of the deployments that we do are too big. We always end up with, every single time I deploy a little test cluster and I play around and I deploy something and it breaks, and I go ask someone saying, here, I have this weird problem. I would say in 50% of the cases, they say, yeah, your cluster is too small. Make all your worker nodes bigger and life will be better for you. And I think that's a problem. We sometimes need for these clusters to be too big, because after all, the idea about containers is that they're lighter weight, less footprint, more efficient use of your resources. I don't think we're necessarily always, fulfilling that premise, if you will. And that goes into details about how do I find the right specs for how much memory do I need to reserve? What's a real live usage of this thing? And we feel that sometimes our teams are throwing in random default numbers because they don't know, right? And then we don't go back later and fix them, so to speak, when we have real live use case testing against this, and we figure out that we've reserved N number of memory, and we're actually only ever utilizing, Y number of, and so then, can we adjust the resource requirements in the individual resources to be optimized and so forth. And I feel like there's a lot of good work that can go in there to just reduce footprint overall. And by the way, one element of that is image size, right? We've seen images that are ginormous. We've had this one team that said, we can't certify our image with Red Hat. And we said, why not? And they said, because our upload times out every time. And then we went in and we saw that their image was 20 gigabytes in size. And then we said, whoa, okay. And then turns out that the image certification site was not really geared to picking up a 20 gigabyte kind of image. And we said, why is it so big? And they said, well, because we put our entire database in there. We basically loaded all of our database into a single image. Now you can have a discussion of whether an image is the right place to have a database inside or not. But that was it, right? So, but in general, I think we found lots and lots of opportunity to make images smaller, to kind of pay attention to, how Docker files are being built, and how images are structured and so forth. And I think we're learning new things every day in that respect. I talked a lot about Helm and Operator, so let me skip that for a moment here and talk about versioning. And that kind of relates to the OLM topic maybe, and then I'll save security for last. OLM in general is a beast. We cannot assume that we've mastered it. There's this guy, my colleague Chris here that I work with, who is, probably the best OLM expert that we have. And even he says he discovers new things in it every day that he can't explain to himself and so forth. And so I think that's good and bad in at the same time. What's good is that, we have good linkage into the operator community and also the people that are driving OLM. We have great discussions all the time. Again, all of it in the open. This is not a hush-hush IBM thing. And I think that's going really well. And we find OLM really useful. And we want to have all of our operators in catalogs. We want them to all be described by CSVs and things like that. At the same time, there's been a lot of churn and change to it, especially over the last 6 months. That makes life hard for us, right? Where sometimes so for example, I think we just had a conversation about there's something coming that works in 4.6, but doesn't work in 4.5. So now we have a piece of software that needs to run on both. So what are we going to do? We literally have a conversation about whether we need OCP version specific catalogs, because they can't span versions and stuff like that, right? And that's been a challenge. Version control is one of those things. We want to use the operators as also kind of the version controller for the workloads that we're deploying. And so there's questions like, how can I do automated upgrades and how does that work? Now, I'm wondering to myself, Karina doesn't know this yet, and whether we should make rollback a thing, right? So how can I do if I'm updating an operator from one version to the next and things break and it doesn't work? Can I pull the trigger and say, oh, let me go back to the previous one and roll everything back? And right now, that's not a first-class concept in OLM, so maybe we need to have a conversation of whether that needs to be versioning in general. And I think that's probably related to the fact that we put commercial software in there, right? We have versions for our software. They have release dates. They have release cycles. We need to upgrade them. We need to make that seamless and so forth. And we're using, like I said, OLM as the vehicle for doing all of that. And that gets also can get complicated to the point that makes my head spin every time. Last point, security scanning. We have more and more customers now that I encounter that are very sensitive to security. They scan all the images, gets me back to my comment about air gap. Sometimes they use different scanners than we use, and they find things that our scanners haven't found, and then there's an email that comes back. It's like, your image so-and-so has 250 violations of our security policy. We shall not deploy it, right? And then we go, whoa, where did that come from? And what is it? And so we have things, for example, where user ID assignments is a very popular one, right? Image scanners would go and check if there is a UID assigned to an image when it runs as a container. At the same time, we are doing a lot of the actual management of, the security and the authorizations. Sorry, there's my phone here. And the authorizations that we use, we're doing that with SCCs. And so there is a question of, okay, what do I need to do in my Docker file to make the scanner happy, even though I know that ultimately the SCC will control what kind of authorization that container will have anyway. I also feel like, so we just had the discussion, for example, we have a couple of pieces in our portfolio that cannot run with the restricted default SCC. And there are reasons for this, right? We're saying, so we have, for example, an ultra-fast data transfer offering called Aspera. It needs access to host ports because it's doing some magic under the covers to ensure that data transfers can be ultra-fast. So it doesn't run on the restricted SCC. At the same time, then we have customers that say, we will not run any piece of software that doesn't run on the restricted SCC, right? So I feel like, so then we need to have a discussion of, can there be exceptions? And if so, how do we articulate those exceptions, right? And how will a corporate security team manage these things, right? And what are the right rules? And sometimes I feel like that as a collective industry, we're still in a learning on learning how to truly run Kubernetes, OpenShift, and software on top of it in a secure way, and what the right governance is that we need to apply to this. So I feel like we're learning something new also from our customers every day, where we're going like, we did this with your software and we found that it's not secure and it could be hacked, and we're going, whoa, we didn't even know. And so now we need to go fix that, right? So I feel like security is still an area where, more learning, more establishment of best practices and so forth has to happen. With that, I think we're out of time.
That was great. I think we could have probably gone on for another hour.
Yeah, I can talk about this stuff all day, obviously.
I think we have sometimes. But thank you again for giving the overview and diving deeper into development. And we had a lot of questions, so that was great. And again, thank you everybody for joining us for this OpenShift Commons with Andre Tost. Am I saying your name right? I guess yeah. After all this time, okay. And I'm Karina Angel, product manager in OpenShift, and join us next Tuesday, same time, for a security discussion. So we'll have Cloud Pak security experts here. So we'll see you next time. Thank you, everyone.
Great lead in from what I just, my last comment then.
I know, that was perfect.
All right.
Thanks again, Andre. And I'll talk to you soon.
Okay.